Yesterday's class we learned about angles in standard position, and that should be good enough to say everything, but then historically there are things that have existed from the past that get carried on. So as like, for example, metric system should be perfect for everyone because it makes things easier, but historically there's still some countries that like things doing the way they used to, so we still have feet and inches, right? We still have pounds. I think Britain sometimes still measures weight in stones. I don't know how many stones I weigh.
Depends on the stones.
Isn't there some sort of horse system of measurement?
Probably. Yeah, they measure a horse by hands.
Yeah.
That's how, this is how tall my horse is. Certain hands tall.
Say like you're one horse tall.
You're one horse tall. No, this is like a 15-hand horse or something like that. So bearings is another measurement that's been used, especially in like ships and stuff like that, in navigation. So if someone says, take a heading of west 30 degrees south, it kind of uses some intuition. West 30 degrees south means starting at west and then going 30 degrees in the southern direction, and that would be the way that you should walk. If you were trying to find a treasure map, they'd be like, oh, I should take my compass out and do this. Okay? This same way is sometimes written as 30 degrees south of west. And sometimes someone says, well, know your bearings. Have you ever heard that expression?
Yeah.
Well, you better know them. I'll teach you how bearings work. Bearings always start at 0 at north. Standard angles start at 0
East.
at east. Positive for standard angle is counterclockwise. Positive for bearings is clockwise. So if someone said go on a bearing of 240 degrees, that would be the same as west 30 degrees south. Because this would be 90, 180, plus 60 more, 240 degrees. So here's our second example of west 40 degrees north. We could also write that as 40 degrees north of west. And we could also talk of it as a bearing of 310 degrees. And just for fun, I'm going to put the standard angle in here from what we did yesterday. Standard angle would be this one. So here this would be 90, 180. This would be 210 degrees as a standard angle. And this one would be
140.
140 degrees as a standard angle. Yes?
You have negative bearings.
You could have negative bearings, it would just mean that you're going around the other way. But they would, I don't know if they ever use that.
You
Yes,
have negative standard angle.
you have negative standard angles. So we could also have called this one, instead of 210, we could have called it negative 150 degrees. And this one we could have called negative 220 degrees. Yes?
I know like the bearings and stuff are used a lot in navigation and orienteering and stuff, but would you ever have to use this in like a map context? Just
Well, if you were solving a word problem like we're about to do, and they give you information in one of these methods, like this next question, well, that's a great lead-in question. It's like I paid you money to talk about this next word problem. They're like, okay, we have this situation. There's a forest ranger. They're sitting out in their forest in their little forest ranger hut, and they see a forest fire. This is like things that forest people have jobs that do this. Look for forest fires. I'm sure that the old school method of actually sitting in a thing has probably been replaced by drones and things that are much more efficient, but It'd be kind of a relaxing job. You just get to go up into a tree house. It's like your little kid. You get to go up in a tree house and just look out at nature all day. And if you see some smoke, you better let somebody know. So here's our forest ranger. We're going to start our forest ranger right here. And she sees smoke rising at a direction of east 40 degrees north. So I'm going to say I'm looking up from an airplane in the sky, looking straight down. I'm going to draw a little cross section here. All right. Do you know how to set up the north, south, east, and west thing?
Never eat soggy wheats.
Soggy wheats. Interesting. Yes, I've always heard soggy wieners.
Nie ohne Seife waschen.
Say that again?
Nie ohne Seife waschen.
There we go. Which means in German, never eat soggy wieners.
What does it mean?
Never wash without soap.
Never wash without soap. Good.
I mean,
Is there a Spanish one?
English.
For
Doesn't work in
remembering?
English.
Yes.
No,
You
not
know-
this one es que yo es.
What is
Oh.
this?
So Spanish students don't know how to do this very well.
Como para olvidar it. No. We learn it like in the map when Europe is in the right, so
Oh,
that's is up in the
Europe's on the right of the map. But what, did someone give you a map that was drawn differently? Then you're screwed. Okay. Yeah. Yeah. So, anyways, however you remember it, this is the situation. We're looking from the top. Here is our forest ranger right there. And they see smoke rising east, so I go that way first, 40 degrees towards the north. In this direction they see a forest fire. Oh my goodness. They see smoke, but you know where smoke is. I have a smoke pen somewhere. Maybe here. Oh yeah, look at that. I think I'm gonna be okay.
You're good?
Yeah, but I'll come
You
see
want a
you.
poster?
Sure.
I'll take a sticker.
Oh, yeah?
Yeah, you wanna make a donation?
$1 donation for
For the
November.
November?
You don't have a dollar?
I do not have a dollar.
Oh.
Just lend Riley $1.
You guys take that?
Yes, in the cap. Yeah, you
We'll
can buy it
get
in
one.
the cap with your lunch today. Okay. Thank you.
So you growing out a mustache?
Mr. Chair, where's your mustache? See Mr. Valentine's mustache?
Yeah. It's- Okay. So, now, forest ranger has like one of those golf viewfinder things. They look out at the fire and it says it's 30 kilometers away. Now, unfortunately, there's not a straight road there. The firefighters have to go straight east and then straight north to get there, making a beautiful right angle triangle. How coincidental is that? To nearest kilometer. How far should the firefighters travel in each direction? So we need to find out this and calculate that. And it makes a nice right angle triangle, so you can use your SOHCAHTOA. Which one do you want to find first, the X or the Y? Doesn't matter.
X or
X.
Y?
Oh, Y. Oh, now we want Y. Okay. If you want to find Y, and you're going to use your 40 degrees and your hypotenuse of 30, we'll use sine, cosine, or tangent. Right? So the 30 is our hypotenuse, and if we're using the 40, then the Y is the opposite side. So we have to use sine, and we can write sine of 40 degrees is the opposite side y over a hypotenuse 30. We can multiply both sides by 30, type this into our calculator, and this is the beauty. This is what makes trigonometry and your calculator so amazing. Check this out. if I type in sine of 40, it's memorized. Okay? Someone would have had to do this by hand a long time ago. Someone would have had to very accurately draw. Wow, that just happened. I don't want. This used to be jobs. Someone would have very accurately drawn 40 degrees. And then they measured how long this side was, how long this side was. So for example, if this side they measured to be 1 meter, and then they went to measure this other side, which I'm going to steal from my calculator because it's already out. My calculator says 0.64278. I really don't like how it did this. That's 27876. Okay, that's as many as I remembered before I forgot. 0.6427. Oh, I think the next one was 8.
I agree.
87. Okay, that's pretty accurate measuring. And once that person said this is an accurate measurement, mathematicians everywhere could say now we can use that accurate measurement and plug it in here, times it by 30, take this answer and times it by 30, and say, I can now figure out this very big question, 19.284. I do 3 decimal places out of habit, but it's to the nearest kilometer, so it's going to be 19 kilometers in that direction. That's powerful. That someone could figure that out. And what's more powerful for us right now is they have put all of those values into your calculator. Okay? And it would be a question, does your calculator have another, like, they also figured out mathematical equations to figure out these. Does your calculator have a mathematical equation that it uses? Or does it just have memory of all these things included? Do you know what happened before calculators? Ask your grandparents if they had graphing calculators. No, if they had calculators in their high school. If they didn't, how did they do trigonometry? Old trigonometry books had the tables at the back. You'd have to turn your back of the book, go to the table, find 40 degrees for sine, and print it out. In fact, they used to sell for scientists and mathematicians. They used to sell books. I have one here. 7-place logarithmic tables. It has not only, this one also has trigonometry. Yeah, well, I'll show you, I'll give you a quick read. Okay, turn to any page, and all it is numbers. This whole book is accurate numbers to 7 decimal places. That's what made this one more famous than the last guy's book. The last guy only could go to 6 decimal places. This guy recalculated everything, did all the math to make everything correct to 7 decimal places. Okay? This is your life's work. Do you think you've just gone crazy? Yes. Look at all those numbers. Right? Check this out.
And then calculate what's happening.
Check this out. Check this out. Signed copy.
Whoa.
Yeah. I have it currently listed on eBay for $800,000. No buyers yet.
You keep it under glass.
Yeah, you don't notice, but there is a little video camera right
Yeah,
here.
the best hiding spot.
Because
is
I
the little
know,
hiding spot. Yeah,
someone's like, oh, $800,000 math book, I'm going to go steal that and read it in my spare time.
It's like an automated set. It should be sold.
So, it's very cool that your calculator has this built in. And it's true for any triangle that has 40 degrees, no matter how big or how small, that ratio is the same. That's the power of trigonometry, which is really cool. And I feel like sometimes you learn trigonometry, you have to play with it for a while, but you should always go back to what does it mean, because it's super powerful. Same thing here. We can set up cos. Cos of 40 degrees is the adjacent side over the hypotenuse. And I can figure this out. Oh, not 40. Sorry, that should be 30, right? And then multiply both sides by 30. Go to my calculator. 30 cos of 40 degrees. 22.98. Oh, I like 3 decimal places. I'll get one more. 28.981. So how far, and it's a word problem. So with word problems, I like you to write sentences at the end, because if you write a sentence, you're not going to lose marks for things that you commonly lose marks in a word problem. You lose marks if you forget units. So by writing it out, they should travel 23 kilometers east and 19 kilometers north. And questions for practice on this one? No.
Is there a story time for this?